Alright, so this is a little video here extending the Lewis structures. And of course we need some practice with these guys. No practice doesn't work. So in honors chemistry we draw this guy out using our typical rules. This guy is 6, this guy is 6 times 4, 6 times 5 is 30, add 2 more, and I get 32 electrons. Separate skeleton structure. And we go like this. And 2, 4, 6, 8, that guy's full. 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, and 32. Ah, nice. Works out perfectly. Put a bow on it with a -2 charge, and we are done. Ah. In honors chemistry, we'd be like, yippee skippy, I am done. All right. But you go on YouTube and you check it out. Well, hold on a second. This is not what they're saying is the answer on YouTube. They're saying it's this. Sulfur, double bond, oxygen, single bond like this. I'm drawing them in the horizontal, but really in 3 dimensions, you would find that it does not matter where I put the double bonds. And looks like that. Okay. So, and again, bracket with a -2 charge and 2 electrons here. Now again, I could have, this is no, still following our rules, we can get this. So following our rules, we can sometimes get multiple versions. Does this violate the octet rule? Yes, it does. And is this okay? Yes, it is. Okay, the sulfur is in the 3rd row, and therefore it can do this. Okay, we get an indication there's something wrong with this guy because it forms H2SO4. So 2 hydrogens jump on this thing to form sulfuric acid. So 1 goes here, and 1 goes here. If all of these were the same, as we might see here, then we expect it to be 4 hydrogens on this thing, not 2. So these 2 do not accept hydrogens. All right, so this is we are going to use an idea what's called a formal charge to see how energetically comfortable the particular atoms are. So formal charges are super easy to calculate. You basically look at how many electrons an atom has, how many electrons an atom starts with, all right, and subtract how many it has, and that's its formal charge. That's the way I would just look at it. Okay. So electrons it had minus what it currently has. So its valence electrons is how many it starts with, and then how many does it currently have. So we would do here for this guy, it's pretty straightforward. You can do this really quickly once you figure it out. The oxygen here originates with 6 valence electrons. How many minus what it has? Okay, so it has 4 on its own. Now these are shared. It only gets half of them, 1 and 1. That's where that half times bonded. So that'd be 2 and 2, but it only gets half of that, 2. 2 and 2 is 4, half that's 2. So minus 2, and that guy therefore is 0. This guy has a formal charge of 0. This guy is identical here, so it's also 0. Let's try this one, this oxygen. 6 minus the 6 it has, and then minus half of that, which is 1, and that's minus 1. This also minus 1. Now all of these guys, you can do the sulfur too, which is 6. It's the same as that one. 6 minus 1, 2, 3, 4, 5, 6. Well, 6 minus 6, it is 0. And then this guy here would be, all these are the same, which would be 6 minus the 6 it's got, minus 1 is -1. So -1, -1, -1, -1. This guy is 6 minus 4, 1, 2, 3, 4, is +2. So all we do here is look at who has the lowest formal charges. Lowest formal charges, again, this is still just on paper, but we typically say lowest formal charges is likely the option that's going to happen in real life. It's more stable, and therefore is more of a common substance that might be actually happening in nature. So if you're trying to guess between 2 of them, only to really know would be to go in lab and check it out. All right, so that's this guy right here. I just did all of these, so I'm not going to do them again here, but you can try. There we go. All right, and there's all the math on that guy. All right, Here we go. Determine the formal charge on these substances. Go ahead and give it a try. So this guy is indicating a 6 minus 2, 4, 6, 7 minus 7 equals -1. So -1, -1, -1. And then the sulfur is 6, and then 2 minus 2, and then 1, 2, 3 minus 3. And this is going to be +1. So +1. This guy, okay, oxygen, is going to be 6 minus. Now these guys are the same, and this one's different. So 2, 4 minus 4, then 5, 6 minus 2 more, so equals 0. This guy is 0, so that guy is 0, that guy is 0. And then keep in mind, we're comparing these atoms here. So this guy is 6. Okay, we just did it here, but minus 6 minus 1 is -1. This guy's -1, just like that. And the sulfur is 6 minus 1, 2, 3, 4, 5. Minus 5 is +1. So overall, this is the lower formal charges because we've got the zeros here. And therefore, this would be considered to be the better option. All right, next one. This guy, what is the formal charge of the central nitrogen atom of this guy? So go ahead and give it a try. And again, how we draw this out, this is a great problem because we can only draw it out so many ways. So nitrogen bonding to nitrogen, bonding to an oxygen. Okay. And we have, let's do our Lewis structure here. So this guy is 5 times 2 is 10, plus another 6 is 16. So 2, 4, 6, 8, 10, 12, 14, 16. I'm going to do it like this instead because of the typically number of times that it bonds. Let's do this way. 2, 4, 6, 8, 10, 12, 14, 16. This guy's short 2 pairs, and this is pretty typical behavior of nitrogen bonding 3 times, so like that. Okay. Again, you could rewrite it in a few ways, but you're not going to get anything different here. Okay, so the nitrogen here, the central atom of nitrogen, so it's going to be 5 valence electrons minus 1, 2, 3, 4. 1, 1, 1, 1. Minus 4 would be +1, and therefore this is my answer. That's a really good multi-step problem, kind of put yourself in a challenging situation. All right, so just a little heads up for you, give them that a whirl. Thank you.